Alrighty folks, this is the big one, the grand finale from where we started, the final class for C++. Now, hopefully I'll get to see a few of you at the last live session, but if not, I just want to go ahead and thank you for taking the class. And before we get to the grand finale, let's go ahead and just wrap things up here. So, what I want to do here is bring us into the course for just a moment here and take a moment to look at all the different things that you've learned. Now, of course, we are still wrapping things up, so there is assignment 9 that is due and will be due at the end of the week, so you still have a little bit of time to complete that. But otherwise, you can enjoy and reflect on some of the learnings. That's what we're going to do today. Another brief recap. And the purpose of the lecture today is to give you, at the very least, all the different things that you've learned in one slide set. So you can always look back and say, well, I didn't understand this, or, oh yeah, this is a feature of C++ that I learned. So with that said, let's go ahead and get ready to dive into the slideshow. So let's go ahead and jump into the wrap up, and I've already got this here, and just one more resource for you. I've brought it up, but this will be a good one for your future C++ to see all the latest events, updates, something called core guidelines, which are proper ways to use C++ or particular features. And as you learn more, these will be great or instrumental for you becoming a great C++ programmer. Okay, so with that said, let's go ahead and jump into our slides. I've got the pre-class form up here, and I just want you to take a moment to reflect on what you've learned with a language and where you want to take things next. So at this point, the course is over, so you've got to sort of come up with your own learning plan. It could be revisiting some of the topics that we've talked about, thinking about taking another course, whether here, YouTube, or some other platform, reading a book maybe. Maybe you'll take on a hobby project, because that's a really great way to learn a project, or through a project rather, to learn some of the skills and make them concrete when you get to see how and where to apply them. And maybe you say, well, C++ wasn't for me, but I did really enjoy some other programming language that I've been learning or using. Well, you can still take some of the ideas that you've learned from the C++ language and try to understand, how would I implement move semantics in Java, or this idea of pointers and accessing memory and having control over allocations. And that can be another way to sort of dive deeper into a language. And that's really one of the advantages of exposing yourself to different programming languages throughout your CS career. So with that said, let's go ahead and get into it though. Last time we discussed some IDEs, various tools that'll come up in C++ when building big projects like Make and CMake, and some techniques like static and dynamic analysis for just furthering your C++ and helping you write some better code. Okay, so this is it, folks. We're wrapping up the course today, and of course, for those who haven't, feel free to use your drop tokens. Just email me as soon as you know what token you'd like to use on which assignment, if you'd like to drop an assignment. All right, and then of course the final reminder on trace, so dedicated slide this time. I think you have a few days to finish things off, but please just take a few moments to do your trace evaluation. This really helps me out as an instructor. Again, helps me improve as an instructor. It's going to help improve this course for the future. And I typically do leave most of my materials up publicly, at least for a little bit. So, you'll be able to reflect on those materials if you visit my site in the future. So. And again, it's likely, I think we've only got 1 or 2 students who are graduating from this class, but most of you might have me again. So I'm always looking to improve and happy to bring that into the next course that you take with me. So, well, see you then. Okay, so if you've hopefully paused the video and taken a few moments to take care of the trace evaluation, let's go ahead and wrap things up. And again, this is just going to be a summary of looking at some of the things that we talked about in this course. So 1 slide per module, roughly. And here's where our journey began. Just understanding again that C++ is not the C language. So we got a little bit of a crash course, but this was sort of imperative, the takeaway that even if you've taken systems, C and C++ should be treated as different languages. While you can write a lot of C code in C++ and use all the C libraries and so on, we really want to think of things as a C++ programmer. I think that'll help you just become a better C++ programmer if you think in that sort of paradigm and are sort of open to the different standard libraries available in C++ and so on. Okay, so that was the goal of that first lecture. The second lecture we moved on to was the batteries included. So this is our first look at all the different libraries that we get on C++. Of course, one of our favorite websites, C++ Reference, had this listed. But again, just remembering that C++ is a batteries included language. Again, if you've learned C previously, you probably saw that you had to implement data structures and stuff from scratch, but that's not the case from C++. We did a little bit of that later on, as we'll talk about with trees, but we really do have a lot of data structures and tools built into the language. And it's important to know that those are available, those are a standard, and you can use them with most data types without any problem and become a more productive programmer. That's one of the reasons people like languages like Python, because there's just so many libraries. Well, C++ is the same way. There's just as many, if not more, libraries. Okay, then we advanced on to learn about functions, different things that we could do with functions, just the general structure, how to create them, some of the semantics of pass by value versus pass by reference. We built a little math library to understand that. Then we learned about some advanced things like const expert versus const for evaluating values at compile time versus just making things read-only values. Okay, and with this lecture, as well as many of our others, we also introduced many different GDB features. So most of our early lectures, we always jumped into GDB. In fact, I'd say more than 50% of the lectures for sure we did some GDB. So that's another important skill set that I hope you took away from this course on debugging. All right, so then we did some input-outputs using some of the standard library primitives for reading in information. And built a really, really simple text editor just to showcase those. So that's kind of a fun exercise there for learning those things and how to parse. And then once we knew how to work with some data, we were also able to talk a little bit about memory. A little bit of a systemsy lecture here, but introduce the concept of pointers and how to use pointers to point to different data. That's the point of a pointer to hold an address of some other data type, and then all the sort of semantics that go with pointers. So dereferencing things, reassigning, the idea of what a null value is, and how we need or why we need pointers when we do dynamic memory allocation to point to a new chunk of memory that our process owns. Okay, so that was a little bit about memory. Then we continued our discussion on memory allocation and layout, specifically talking about the difference between stack memory and heap memory. So heap memory being stuff that you do with new and delete. And stack is memory that's managed automatically for us. Okay, we also learned about structures. So we could structure our programs or the data in our programs as a composite type by aggregating different other types to create the struct. Then we did a little bit of talking about 2D arrays, how to think about them, how to address a 2D array as a 1D array, which ended up becoming quite important for us in a few of the image processing assignments. Okay, then we moved on to object-oriented programming. So this should be familiar for folks who, of course, have taken OOD or were taking OOD this semester, who are up to that great challenge. But just this idea of what goes on behind the scenes for object-oriented programming, just so you sort of understand it if you had a little bit of C background, this idea of pointers to functions and them sort of all being wrapped under the same struct. But then we just kind of learned about the C++ way of doing things. Should be very similar to Java, but one of the differences is that we have these special sort of constructors and destructors with this RAII principle that we had to keep in mind. Okay. Then we moved on and continued our OO discussion, introducing copy constructors and talking about how we have to write those, so sort of the difference between a deep and a shallow copy, and then also the sort of fourth musketeer copy assignment operator, so sort of understanding how that plays in as well. Okay, then a little bit of discussion about how to just structure our projects in general, interfaces versus implementations. And then we got to look at our library, which would become our library for the course, SFML, and see how they break things into interface and implementation, and then how we can use that actual library. Okay, then we moved on a little bit to talk more about library building, because it made sense now that we were going to use a library such as SFML just to understand the compilation process and how to link things together. So there was a nice little bit of discussion about that, and then a nice bonus video for those who watched to just understand what's going on with the source, preprocessor, and so on, to understand the full compilation process. Okay. All right, and then we moved on to some more object-oriented programming. So this idea of how to sort of structure different projects, use inheritance, and so on. And then we did a review of just sort of building some data structures and learning about trees at this point. So we learned a little bit about inheritance and so on, and then a little bit about doing an implementation of a binary tree from scratch. Okay, so we continued our building sort of data structures discussion, continuation on trees as well, some of the use cases, and I believe I continued some of that implementation of the binary tree from scratch. Okay. Okay, so then we moved on to, now that we can sort of build our data structures and understand inheritance and so on, we then moved on to the Falling Sands project, did a little bit of a walkthrough there, so you got to see again some more object-oriented programming, how to separate out a project, how to design a little bit when you're going to do a different, project and sort of some project that's going to be a little bit larger at scale. So this was a walkthrough of that assignment. Then we learned about smart pointers. So at this point, you've been using just regular pointers and maybe running into various errors with forgetting to free them or delete them or so on. So we learned a little bit about how smart pointers can automatically manage memory. So, for those who are missing Java at this point, smart pointers are a way to help us allocate and manage our memory without having to think too much about different issues that could happen for double freeze, dereferencing null pointers, and so on. Okay, so we learned about the 3 different types: unique pointers, shared pointers, and weak pointers. Okay, then we moved on to talking about templates in C++. Now, we had been using templates in things like the standard library, the standard template library, that is. But now we learned how to create our own templates. Just another word for generics, C++'s version of generics that you got to utilize for primarily functions, but could also be used for classes as well. Okay, then we did a review at this point because we had learned a lot, sort of interview style. So, a collection of real-world questions, mostly ones that I had been asked for my interviews, internships, and full-time positions and consulting gigs, just so that you were aware of this. And just the other tip that you should always write down your interview questions after your interview so you can go back and practice and always get better. Okay, then we talked about graphs related to trees, but the sort of generic implementation. So the definitions, and then we focused a little bit on the data structure implementation. So we looked at adjacency matrix and adjacency list and did a little bit of a walkthrough of implementing an adjacency list to build that data structure. Okay, and related to graphs, once we had this idea of nodes and sort of edges between them, we implemented splines. So another sort of implementation of a graph here, but a specialized one, and got to use a little bit of these math libraries. So we built a linear spline as an example and learned about some of the lerp functions and some of the numeric libraries and so on. And then for your homework, you're able to do a walkthrough and implement the Catmull-Rum spline, which is famous for Ed Catmull and Rum, of course, from Pixar. Okay, then we got to do another fun one and learn a little bit of a design pattern doing some animation by building a sprite class and then a resource manager, and talked about how a resource manager, and we can utilize some of the data structures we've used, things like maps, to pick out resources that have already been loaded and just reference the same resource. So we saw how that could save us on memory and space and so on. So that was our first sort of design pattern to learn some of these, how animation is handled, again with our theme of working with pixels in this course. Okay, then we moved on and said, okay, how do we make things faster and improve performance? And we learned a little bit about threads. So this is dipping a little bit into systems, but just the idea of some of the things that can happen with threads with deadlock and data races and some of those things, but how C++ provides us this threading library and how we can use things like mutexes or atomics to protect our data. We also spent some time looking at asynchronous functions and promise futures so that we can again, have work going on behind the scenes in a background thread while we make progress. So that was, we did some work with the asynchronous stuff there. So that was pretty cool. And this was also our first introduction to lambdas, which are available in C++, the way to write anonymous functions. So super powerful and cool tool that we can use there. All right, and since we talked about threading, we had to talk a little bit more about threading just to do some more examples with async. And then we did a little bit of work with the understanding that C++ has a memory model, or a guide of sort of how these operations have to take place. So we at least have a reference for that. We know that it exists and it's important to the development of C++. Okay, and then we did another little exercise while talking about the memory model and just memory in general, with just overloading new and delete operators to show how that could be done, and sort of tag our memory and see where our allocations are, and then just understand where our performance could be. Because maybe if we're allocating a bunch of memory in different threads, for example, we would want to know which thread we're allocating memory in, or if we have forgotten to free memory within that thread, and so on. So that can be a useful trick for us. Okay, and then we moved on to iterators and algorithms. So iterators were sort of hidden from us. We were sort of doing our loops through a collection like myvector.size, for instance. But if our intent is to look through an entire collection or traverse through it in a certain way, maybe it's a graph or some other, or a map, some other data structure, then we have iterators built in which allow us to do this, and they can be super helpful. Then we saw how those iterators could be useful and applied within the algorithm library to help us actually use some of the built-in algorithms in C++, things like sorting, copying, reversing, finding unique elements, swapping, and so on. And again, we just have this very powerful and expressive library built in and available to us for free. Okay, and then we got into some more advanced stuff in C++ towards the end. So we had our copy constructors, copy assignment, our constructor, destructor, and yet there is another constructor to consider, and that is the move constructor. But more in general, just this idea of move semantics, this idea when we can move data instead of making a copy to transfer ownership from some source to a destination. And that way we don't have to make lots of copies, and copies can be otherwise expensive. All right, and then we moved into this week's sort of flex topics and talking about PyBind and how that can be useful to take advantage of an interpreted language, whether that's us building a C++ library and calling it in Python, which we did a little example in, or otherwise you could embed Python into C++. So I had a series of videos for that if that was something interesting that you wanted to explore. But just knowing that this functionality is there, and again, it's one of the powers of C++. Again, most of the Python code and stuff that you're calling into the libraries are probably C or C++ code because you want the performance. Okay, so just some fun examples there, and then just understanding or reiterating that C++ is a compiled language and it's good for performance, but maybe not as good for iteration time if you're trying to rapidly develop an idea. So balancing a compiled and an interpreted language for the same project is something that many large projects do to make the programmers more productive. Okay, and then our other flex topic was sort of using graphical user interfaces, but again, a little trick to get you compiling big pieces of source code. So we looked at WX widgets and just briefly how to do that. It would be a teaser for our lecture, our previous lecture with using tools like Make and CMake. You got a little brief run through for this, and I think it might inspire some folks who want to go back to some of the other assignments, maybe add a graphical user interface. I think WX widgets is a good library for that, and there's lots of examples that you can play around with. So a nice look at some more C++ code and code bases. All right, and then we had our last flex day, the last class, discussing IDEs, some tools like Make and CMake, just a little bit more detail, so you had some resources when you encounter those, and then discuss some static and dynamic analysis tools for, again, going further and helping improve your C++ as you take this course beyond, just what you've learned in this course and into the future. All right, and that brings us to the summary here. So I'm going to bring myself back in here in the small window and just say, it was a pleasure to teach all of you and have you in class. I hope you're leaving this class excited about C++ and excited about learning more things related to C++. The language is evolving just like any regular language evolves, and there's plenty to learn. I particularly like C++ because it's a language that scales as you become a better computer scientist, programmer, developer, data scientist, whatever you want to grow into. And really that's a great thing about the language. It has multiple paradigms and so on. So if at the least that's your takeaway, or you can appreciate the language, I think Java is successful if you can appreciate applying or using C++ in some of the projects, and maybe you'll take some of these projects and implement them in other languages if you didn't enjoy it otherwise. But otherwise, I hope you plan on keeping to grow, learn new things. At Northeastern, consider looking at some of those conferences or some of the resources that have been posted if you didn't get a chance throughout the semester, so you can continue learning. And, for some of you, this is congratulations on graduating. And for others of you, this is, well, we'll see you in summer 2 or the fall in future classes. So really looking forward to that. Thanks again for taking part of this class, and we'll see you folks soon. All right.